Hello space fans and welcome to another edition of Space Fan News. This week, the joint European Space Agency and Roscosmos EXOMars mission arrives at the red planet and, well, it's a snag. And also, NASA's Juno probe runs into an unexpected glitch as it makes its second scheduled close approach to Jupiter. Well, it has been a rough week for us space fans interested in the understanding and the exploration of the solar system. This week, on Wednesday, October 19th, ESA's EXOMars mission, which I've reported to you many times in the past, arrived at Mars. And if you'll remember, the mission is split into two main parts. There's the Trace Gas Orbiter, which is designed to stay in orbit above Mars and look for small traces of methane and other gases in the Martian atmosphere that may provide clues to the possible biological or geological activity there. And there's the Entry, Descent, and Landing Demonstrator Module, or EDM, which they're calling Schiaparelli, which was designed to land on Mars and test some of the technology that will be used by ESA in future rover landers. So the timeline goes something like this. On Sunday, October 16th, the preparations for the exciting Mars approach began. First, the TGO gently pushed Schiaparelli away from the main orbiter, and the two spacecraft kind of flew in formation as they approached the red planet, and shortly after separation, the lander was put to sleep. Now, everything was going well. Both spacecraft appeared to be in great shape, and at the appointed time on Wednesday, the TGO started its burn to keep it from crashing into Mars, while the Schiaparelli probe continued straight to the red planet. Also, about 75 minutes prior to landing, the lander was woken up and everybody verified that the lander had the information it needed to make the descent and landing. So now, by this point, everything's going great. The TGO orbital burn is happening and the Schiaparelli probe is awake and on its way. Now, since it takes over 9 minutes for communications to reach the lander, the commands to get it to descend and land are already loaded because so much needs to happen so quickly. So it was left to do its thing, which included getting through the atmosphere, ejecting its heat shield, and firing its landing rockets. Well, meanwhile, the TGO finishes its burn and everything is looking great. The EXOMars Trace Gas Orbiter is in an elliptical orbit around the planet Mars. But sometime during the 6-minute descent procedure, contact was lost with Schiaparelli and was never regained. So as it went down, however, telemetry was continually sent from Schiaparelli to the orbiter as it went down. And very soon after they did not regain contact with the Schiaparelli lander, the TGO started sending that telemetry back to Earth. So as soon as the data were received back at headquarters in Germany, it was partially analyzed and they confirmed that both the entry and the descent stages of the lander occurred as expected. Where things got kind of weird was from the expected point of the ejection of the heat shield as well as the parachute. This ejection appears to have occurred earlier than expected. And they also noticed that the landing thrusters were briefly activated and it seems likely that they switched off sooner than they expected at an altitude that was probably pretty high. So that was yesterday. Also yesterday, NASA's Mars Reconnaissance Orbiter, or MRO, took a picture of the expected Schiaparelli landing site, which they compared with a picture of the same area taken back in May of this year. Now, this before and after series shows the appearance of a darker smudge in the top left quadrant of the landing zone and a bright white dot near the bottom. The bright dot is probably the lander's 12-meter diameter parachute, which was deployed by the descent's second stage. Darker smudge is likely evidence of the lander. So they're thinking that either Schiaparelli's impact or a possible explosion disturbed the Martian surface, which uncovered darker material that resulted in that black blob we see. So what they're thinking so far is that there was a premature shutdown of the lander's thrusters that put it into a free fall 2 to 4 kilometers in the air. So if that's where it happened, then that means that the Schiaparelli probe would have hit the ground at over 300 kilometers per hour. And since the fuel tanks for the thrusters were probably still full, it's likely that the lander exploded on impact. So of course they are still going over the data, but it's not looking good for the part of the EXOMars mission that was designed to land on the surface. So one thing that occurred to me when this was unfolding is, remember back in SFN 157, I reported on that trail of debris that was following the spacecraft after launch? I can't help but wonder if there was something there that may have attached to the lander or affected the lander in some way that perhaps wouldn't have shown up on the tests that the engineers did after they fired up the spacecraft on approach to Mars. Now, I'm not suggesting this was related because the mission said it wasn't an issue, but I did think about it this week. Next, also on kind of a sad note, NASA's Juno spacecraft entered safe mode as it approached Jupiter during a second scheduled close approach, which they're calling Perijove 2. Apparently what happened was a software performance monitor induced a reboot of the spacecraft's onboard computer on Wednesday Eastern Time. So Wednesday was a really bad day, really. Now the spacecraft is designed to enter safe mode if its onboard computer perceives any kind of conditions that don't go as expected. And in this case, the safe mode turned off instruments and a few non-critical spacecraft components, but it also confirmed that the spacecraft was pointed toward the sun to ensure that the solar arrays are still receiving power. Also, the high data rate from the spacecraft has been restored, and Juno is currently conducting flight software diagnostics. Since all the instruments are off, and this occurred when Juno was 13 hours away from its next close approach, and when data are the most interesting, the science data collection didn't happen during this flyby. Now, there was also an unrelated issue that happened last week with the performance of a pair of valves that are part of the spacecraft's propulsion system, and the decision was made then to postpone a burn of the spacecraft's main engine that would have reduced Juno's orbital period from 53.4 days to 14 days. So Juno is in a bit of a state right now. The instruments are off while system diagnostics are being performed, and the orbit is not what was expected at this point in the mission. Now this is sad because Juno is in a bit of a zero-sum game here. Even though the instruments are off, the harsh environment of Jupiter is still causing the degradation of the sensors and the detectors. The mission was designed with a specific number of orbits that allowed for the maximum science to get done before these detectors became unusable. So every orbit missed is really expensive because those detectors won't be the same when they approach Jupiter again. The next close flyby will be December 11th, and NASA fully expects all the instruments to be on and working. And of course, I will keep you posted. Now, the Juno science team is continuing to analyze data from the first close flyby on August 27th. And what they've learned from that flyby is that Jupiter's magnetic fields and the aurorae are bigger and more powerful than originally thought. And Juno's microwave radiometer instrument, or the MWR, also provided data that give mission scientists their first glimpse below the planet's swirling cloud deck. The radiometer instrument can peer about 215 to 250 miles, or 350 to 400 kilometers, below Jupiter's clouds. So, good stuff has happened with Juno right now, even if we are in the middle of a bit of a nail-biter here. What's also cool about this mission that I haven't really gone into very much is the onboard camera they're calling Juno Cam. The Juno Cam is a public outreach camera that was operating during the August 27th flyby. The raw images of that flyby and all the flybys are made available on the Juno Cam website for the public to study and not only look at, but to process into final image products. Juno Cam is the first outreach camera to venture beyond the asteroid belt. So you can go there to that website and process the images from Juno Cam directly, and you know you want to. The link is in the description box below. They have a small operations team and no image processing team. So what they're saying is they took a leap of faith that the public would step up and help them generate images of Jupiter from the raw data itself. So get out there, folks, and start processing. There has never been a better time to be an amateur interested in astronomy than now. With all the citizen science initiatives out there like this one, from NASA's Juno mission to other efforts like Galaxy Zoo, you can get involved and help astronomers like never before. And I know a lot of you have already been doing that for some time. Well, that is it for this week, space fans. Thanks to all SFN Patreon supporters who make SFN possible. I really could not do this without you. Thank all of you for watching. And as always, keep